Hello, how's it going? So today I'm joined by FD, and we're just going to be going over a bit about chain signatures on the lead up to Redacted, and he's looking to build something with chain signatures, and he's a bit of a novice to chain signatures. He says knows like a higher level understanding, but hasn't got into the code. Um, yet. Do you want to introduce yourself and talk about what you're planning to build in Redacted and what your like understanding of chain signatures and chain abstraction is so far?
Yeah, hi, I'm Efte. Yeah, so where I'm coming from, I'm a long-time new ecosystem member, and I've started to build like, I guess, a year ago, and I'm quite fluid in reading and writing smart contracts in Rust or Near. And due to me having a limited experience in developing, I have a tough time getting into new areas myself. That's why I'm thankful for getting some help with chain signatures, diving into them. And we would like to create something that is like order book cross-chain, where people could basically swap tokens regardless of the chain they're on, for example, near for ETH without any bridging, just one person creating an order and the other person sending the counterpart and receiving what was deposited. And then, yeah, that's the end goal. That's what I would find pretty exciting about chain signatures, being able to create centralized exchange experience without any funds being locked up in uh, some place that you have no control over.
Yeah, I think this use case is like one of the most, maybe not common, but the thing that comes to you first when thinking about chain signatures. And it's, whilst it's something you might think of quite early, it's a really cool use case, and hopefully we can learn how you can do that today. So I'm just going to share my, let's see, I'll share my entire screen and let's see how we go. Maybe we'll get the infinite mirror. There we go. And then I will think I should still be sharing my screen now. Yeah, so we'll go ahead and dive into this repo. Can you see my screen?
Yes.
Awesome. And we'll go into near docs as well. So this is just the basic near multi-chain example. That is a basis for a lot of what people will be doing with chain signatures. And we'll come over here to the documentation. And if you go into chain abstraction services and chain signatures, because chain signatures is one of the products that allows us to implement chain abstraction, basically. And what's your understanding of how chain signatures is working at the moment?
Yeah, so on a high level, it's for me very superficially a near account controls accounts on other chains that can be derived through derivation path. So some combination of letters and numbers, and that always create the same public address. And then you can sign arbitrary messages through an MPC contract that are multiple MPC contracts where the private key is split between all of them, and they together create the signature for this arbitrary message. But I don't know how exactly that works, but that's my understanding of the overview, basically.
Yeah, it's a pretty good understanding. I would say that that's mostly like all the understanding you need to know about chain signatures to go ahead and implement something like you're wanting to. I think to go a bit into more about how the MPC contract works, like you said, instead of having a private key to sign something, the private key is sort of sharded between multiple nodes, multiple MPC nodes, and then these come together to sign the message that you want to sign. And this and it works through like threshold cryptography, threshold signatures. So you have like n of m nodes to sign this transaction. So you'll have like 5 out of 10 nodes or whatever that need to sign it for it to be successful. And
I have just a question in terms of how do we decide, or where is the chain that we want to interact with defined? Because especially on Ethereum, you have a lot of layer 2s, and this is Ethereum as well. So I was a bit confused of how through the derivation path it determines what chain we are on, or is the derivation path just doesn't it need to be Ethereum 1, Ethereum 2? Could it be an arbitrary combination of letters and numbers? It's just standardization, so that every first Ethereum account of a certain new account is called Ethereum 1 to have the wallets, for example, always talk to the same wallets at first.
yeah, good question. So the public key and then thus the address of the account you're going to be sending transactions from on like Ethereum or Bitcoin or some layer 2 will be first it will be based upon the public key of the MPC contract, MPC service, plus what account you are calling it from. So if PyVortex.near or PyVortex.testnet calls it, then it's going to be different than like iSpice.near or iSpice.testnet, my other account calling it. So it separates the addresses from one person to another, like you were saying before. And then you have the option to add in some metadata or an additional like derivation path. And that can either be nothing, like an empty string, or anything you want it to be. For example, you can see we have Ethereum 1 or Ethereum 2 here. And at the moment, there's a lot of wallets building in the space, and they're coming up, and we're all trying to decide on how these derivation paths should be structured. So, for example, if you have a multi-chain wallet, then you want to clearly define which account you're actually going to be using, so you don't have to store these derivation paths on chain. So everyone could say, we're all for our main Ethereum account, we're all going to be using Ethereum 1, and then we're all going to be using Arbitrum 1 or whatever. But right now, there's not set standards. I believe these are coming, so you can just really use whatever derivation path you want.
Okay, cool. Yeah, I just remember using a Bitcoin wallet, and there's the option to create new wallet in the private key that you have input. And I did this with 2 different wallets, and creating a new wallet wasn't creating the same address, and therefore I wasn't able to access my second wallet on the other wallet, if you understand the issue. So yes, I'm looking forward to for the wallets having the same standardization process there.
Right. Yeah, I get you. So we'll look at implementing chain signatures now. So this is in the documentation, and it talks about the steps to sign a transaction and send it to the network. So the first one is you need to derive the address of the account that you're going to be using on, say, Ethereum. We'll probably just use the example of Ethereum today. The next is creating the transaction that you want to be signed, and this can either be done in your front end, which we'll look at in today, or you could create the transaction in a near smart contract, so you can only perform certain actions, right? Then requesting the signature. This is when you get the contract to actually sign the transaction, and have the service sign the transaction. And you just basically send the transaction payload to the contract. Then reconstructing the signature, basically, once you've got the signature from the contract, you get it back in your front end, or and then in step 5, you broadcast that to the target chain, because when you're signing the transaction, it doesn't necessarily mean it's being sent, because signing and sending is a different process. You could technically sign a transaction and not send it, and then send it like at a later point, which is a bit of a security issue, and you need to like index what transactions are being sent, but that's a bit later down the line. So yeah, we'll dive into this example here. It's split up into the different sections, but it leads to this near multi-chain library, which you can just see in near examples. So let's go ahead and clone this.
Does this support layer 2s already, or is everything at the moment just for Ethereum, mainnet, and Bitcoin?
So because chain signatures is basically like chain agnostic semi, so you don't need to like integrate a new chain, as long as it's using the same keys, like the same public key types, which is ECDSA, then it will be automatically accepted, and you can use it.
We define the destination chain then in the example.
Yeah, but yeah, this example is just Ethereum and Bitcoin, so you'll need to change some things if you want to interact with like Arbitrum or some other chain that uses like ECDSA. So I'm using WSL here. Git clone this example. Let's enter it. Oh, bad spelling. I need my glasses on. Install everything. Let's enter it first. So there's been, I don't know what's happened there. Oh, I think it's because I got halfway through installing everything. But yeah, there's the signing service, the signing contract specified in this example has had some congestion issues recently. So we'll actually swap to a different one. And this will be good to show you how you can swap anyway. NPC contract near, and this should come up. Here we go. So this is the repo of the contract that you actually use to sign things. You don't need to really look into this too much, but it's useful to understand how it works. And we'll get into this later, and this is like the interface of how to interact with it. And here's some examples, and this is the example in the contract, but we'll swap over to this one. Let's enter in. Okay. So let's take a look at this repo. How is it structured? We just have a basic, I think this is Next.js or something project. So we have our package and our source folder is what we're going to care about, right? And we have some pages. We have our app. We have our CSS, whatever. We have some global context, which will just have like a wallet and signed account ID. This is pretty standard for a near project. You go into another example like the guest book, and it's basically set up the same. But what we really care about here is the So we have like more front end stuff for Ethereum and Bitcoin and the navigation bar. But what we really care about is this services. And we'll look at Ethereum. This is basically, you'll use all these functions to perform everything you need to, like those 5 steps, and these are split up into different functions. So we'll look at deriving an address. So we see here that we have this function, derive address. It takes the account ID, your near account ID, and some derivation path. And from there, it will figure out the public key and then the address of the account you're going to sign the transaction for. So we'll look at that function in the code. And like I said, I wanted to swap to a different signing service. And you'll see here we have public key and we await some function call, which takes our account ID and derivation path, and then this big, long, complicated function, which is defined in this KDF file. And this has a public key of the MPC contract defined in it. And from there, we use this to get the public key we want. But we have where are we? I think it's in app. Yeah, this is where the MPC contract is defined. So we'll swap that out for dev. Feel free to jump in with any questions if you have. And then we're gonna have to
follow you on my computer, but I think I got it. So there's
cool.
The MPC contract is one contract, but it calls other contracts that have part of the private key stored or can derive part of the private keys.
But not other contracts. Oh, it's like an off-chain service.
Okay.
But yeah, we need to change this root public key because we're changing the MPC contract. So we'll have to figure out what it is. We can do that by going to near blocks testnet. And let's insert our contract. Go to contract methods. So what is this going to give? Public key. This looks like a function that will give it. So I'm gonna see what the public key is. Near contract call function. It should be a view function. This account and public key function was called. You shouldn't need to do this if you don't need to swap MPC contract, and it should have empty arguments, testnet. Aha, here we have the public key of the MPC contract. Let's go ahead and change that. So now we'll be able to interact properly with the other one.
So the address was v1 signer minus dev.testnet instead of minus prod.testnet.
Yeah. Okay. This is like the latest version, but at the moment the production one's being a bit slow, so you can swap over to this one if it's having any issues. And you could even have it in your code that says, hey, let's try get a signature from here. If it doesn't work, let's swap to this other signing service. So yeah, this bit is pretty simple. It just takes the public key of the MPC contract, the MPC service, and derives a public key for you. And this is going to be like Ethereum. Well, this will be just like a public key. I think it's it's this key type. and then you can change this key type basically. If you were going to use like a chain with a different key. And then once we've got the public key, we get the address from that, which is specific to Ethereum. So if we look in here, yeah, it has some Ethereum specifics, and then there's a different function for Bitcoin, because if we look in this Bitcoin file, it uses this uncompressed hex point to BTC address instead of ETH address. But basically, you don't need to understand how these things are working, just copy it and fork it. Like, I would strongly suggest that you just fork this repo as your starting point. So we know how to derive the address now. Any questions about that?
No, we're good.
Cool. So let's see what the next step was. So we've derived the foreign address. Creating the transaction. Okay. So let's go back to our code. In this example, we can create a transaction to just send Ethereum from one person to another, or we can create a transaction to call some contract on Ethereum. And this is the function to do so. I think is it called create payload or create create payload. So a payload is more of like a compressed version of a transaction, and this is what the MPC contract requires. It doesn't require the whole transaction. So this is how we're constructing a transaction for Ethereum. We have our nonce, which is basically like which number transaction is it, so we don't like repeat the same transaction. We have our gas limit of how much gas we are willing to spend on this transaction, max fee per gas. I think this is like how much we are willing to spend per gas. I don't know too much about Ethereum. And something similar here if you want it to be a priority transaction. And we just get this nonce from some Ethereum utility. This is like Ethereum specific, so you'd have a different one for Bitcoin or some other chain. And we just get this from querying gas price on Ethereum as well. Then who are we sending this transaction to? We're just going to input that. So this can be a person or a contract. Data will be what's like actions are we performing. So we'll go into that a bit later. So you can have just empty data if you want to just send a transaction. Value, how much Ethereum are we sending? We're going to enter that. And chain, like what specific Ethereum chain are we sending to? And I think this is, where's chain ID? Let's have a look. It's defined in here. So we're sending it to Sepolia, which has this chain ID. Okay. So that is basically how we're creating the transaction.
How did you get from this chain ID to the actual chain ID number in the other file?
What was that, sorry?
How did you figure out the chain ID that was hard coded in the other file?
I believe you can just search that up, like Sepolia.
Oh, I was wondering
chain ID.
what the path was for you to figure out to get to the hard coded chain ID.
Like this one?
No, you saw chain ID, and I wanted to figure out how you got where this value is
Oh,
stored.
how I
Because,
found out where it was.
yeah, because when I click on it with control, then I only get to export class Ethereum, and then there's a constructor, and I don't get to the other Ethereum part, so I can
Yeah.
find this the next time I see it in another file.
Yeah, for sure. So I just saw it was part of the class, right? And then yeah, it's part of the constructor. So when you're creating the class, that will be specified. When you're creating the object of the class, that will be specified. And I just knew from interacting with this library that that was created in the Ethereum component.
Okay.
See, this is where we're creating it. The ETH object, which will do like ETH dot create payload in our component, and we specify the RPC and the chain ID.
Well, cool.
We'll look a bit more at the
So
front
if we
end
change the chain ID, we also have to change the RPC, I suppose, because it's a different chain then.
Yes, I would believe so.
Okay.
So yeah, there's different RPCs here. So if we go to like Ethereum mainnet chain ID, chain list, this is a useful website. Maybe it has it here. Ah, yeah. So we can get the RPCs for Ethereum mainnet if that's what you're doing. Oh, this website seemed to broke my Google. Give it a minute. Any questions whilst it's there? We go.
I just out on the website so I can interchange it as well.
Yeah, so back to creating the transaction. So we specify the transaction data, which is made up of all of this. And then we get the transaction by just using this function, which is some external function in another library. But again, you don't really need to know too much about how the inners of these functions are working unless you're going to change a lot. You can just sort of use create payload. And then we get the payload from the transaction. There's a thing here where we're storing the transaction because basically to pull the transaction back together at the end, we need to have one, the transaction, and two, the signed transaction hash, and then we'll merge them together, which we can actually broadcast to the network. So this create payload is outputting the transaction and the payload, and you can see that we're storing it here, but we're also returning it. This is because if you're using a web wallet, then it's going to have like a redirect and you'll need to save it in storage because any information you had just in the browser will be lost unless it's saved in like session or local storage.
Yeah, good.
Okay, so now we've created the payload and the transaction, we can request the signature. This is the function you call, which takes the wallet, the contract that we're calling, which was, can you remember what it was called? This one, v1 signer.-dev.testnet. And the payload, what we're actually going to send. So we call this method from by using the wallet, and that's just specified in this wallet file. You can learn more about that if you want. It basically is just doing a call method and sending it, broadcasting it via RPC to the near chain.
Yeah, I've done that before in front ends that are not transaction.
Nice. So yeah, we're calling this contract. We're specifying the method. The method is just called sign, and the arguments, we saw this earlier. Where was it? Over here. So the sign method just takes a request, and this request is an object which has the payload, the path. The path is where we were talking about before, like it could be nothing, it could be Ethereum 1, Ethereum 2, whatever you want it to be. And then key version, which is just like if the contract changes, then they can update the key version. And at the moment, it's just set to 0, as we'll see. Yeah, so we put the payload, the path, and 0 key version.
And therefore checks that the signer of this transaction is the same one that is associated with the derivation path. So I wouldn't be able to sign a transaction that is from the derivation path of another account.
So this path is different to that path. This is like a smaller path. The larger path comes from your account ID and this path. And so basically the MPC contract will look at the predecessor account ID, like who sent this to the MPC service, and their derivation path will be based on your account ID. So it's handled in the MPC contract, if that makes sense.
Yeah, makes sense.
So we just attach some gas and we attach a deposit. Here we're attaching 0.05 near, but this deposit will change based upon the like how congested the MPC service is. So it goes from like 1 yocto near, which is the smallest amount of near. It's basically nothing, but it just needs that amount of near to have the wallet pop up because you're doing some like vital transaction that where you have to clearly accept and sign the transaction. And then it can go up to something like, I think it's 0.7 near, 0.65 near, I think it is, which is quite expensive, but it's unlikely to get that high. And whatever deposit you attach, if it's not using that amount of deposit, you'll get it sent back. And again, if the signature fails for whatever reason, you'll get the amount of deposit sent back. So I could attach like 1 near if I wanted and get everything back, but we're just attaching a small amount of near. And then this will give us big R, S, and recovery ID. I'm not particularly too sure about the details of this. It's just like the signature is split up into 2 parts. And once we've requested the signature and got this information back, we reconstruct it, because this isn't giving us the signature straight away. We have to get the signature from here. So we're adding the signature to the transaction that we got earlier with this R, S, and V values. And you don't need to know, again, you don't need to know the details of this too much. And then we just have some code to check that the signature is proper. And like I said earlier, there's this reconstruct signature from local storage, just in case we're using a web wallet, because we won't actually get this information back. We will have to fetch it from the RPC. And then finally, once we have this signature, with the signature being added to the transaction, it should really be called maybe signed transaction instead. Yeah, well, it's called signed transaction here. So we we serialize it, and then we use the RPC to just send that transaction to the blockchain we want to send it to, and then we'll probably fetch some receipt for that wherever. I think that's done somewhere. So basically, that's the inner workings of the methods we're going to be calling. So we can look at the component a little bit here, but it's quite simple. We're basically just like deriving an address based upon the account we're logged in with and the derivation path we're putting in. Once that's set, when you click a button, then we'll request the signature. Once we've got the signature, we will say the signature is ready. Look, signed payload ready to be relayed to the Ethereum network. So once we have that signature, it'll say relay signature, and at that point we relay the transaction, and if it's successful, we'll get successful with the what do you call this, like a Etherscan link, so we can check the details and check everything was all right. Any more questions, or we can actually look what the front end looks like?
Oh, I'm good. Let's get into the front end.
Let's go. Hopefully everything will work. So we'll just do yarn dev. Remember, we did yarn install before. Let's take a look. Okay, so I'll need to log in with my account. Oh, do I have? I'm on a different thing here. I'm on a different browser, so I'll have to open up this one.
Can also
Copy.
just quickly create one in the console.
I don't want to add my account to the DevHub one. Someone else might steal my testnet tokens.
No, that's what I mean. You could just create
Yeah.
create an account quickly.
Yeah, so I already have my accounts and I have some funds on that, so I can just quickly do things. So yeah, you just come in here, log in with a wallet or create a wallet. So I have a few accounts, so I just sign in.
So basically, you can do this without a wallet. This is specified to handle signatures from other chains, because you only need to sign transactions on near. The only issues with wallets that don't have a standardized way of displaying the paths is that you don't know your balance, right? Because you can't really look it up, because there's no interface, because there are no wallets supporting these on mainnet yet.
Yeah, so at the moment, like, if we went to our wallet, we wouldn't be able to see how much Ethereum I have on this account. We could create one of them as a hackathon project, because why not? That would be cool. But we can see that when we come into here, it shows how much ETH I have based upon my account and my derivation path and what chain I'm on. So if I swap, I can swap to Bitcoin. But go ahead.
That is Sepolia then.
Yeah,
right?
yeah, this is Sepolia. So if I change this derivation path to something random, then I have no balance on that.
Okay,
but
yeah. I just tried to get myself some Sepolia test. Not really have a link for me.
Well, I'll go ahead and do some now. So I have it in my browser already. I think this Google one is quite good. I'll send that over to you.
Cheers.
Sepolia. This, not that. So when I put in the path, you'll see that the address will change based upon that path. And the same would happen if I was change wallet. So I'll copy this path and put it in there, and I'll get some Sepolia. But what you might want to do is, instead of sending the Sepolia to just one address that is connected to a Near account for testing, you might want to like send it to a MetaMask so you can send more refined amounts to each account if you're testing, because say you were to forget what derivation path it was, then it wouldn't be too good, because these things are like rate limited. So if I refresh this, then I should see that there's balance. Yeah, I've got 0.05 ETH, but I'm going to use this one I had before. Ethereum 1. Have you got a Sepolia address I can send you ETH to? FT?
Oh, sorry, I was muted. I was just requesting Sepolia for.
I'll just send it to this
I'll have
random address.
0.05 ETH. That's how it went through. My near-derived Ethereum 1 account actually has now some Sepolia. That's already exciting.
What is your address? I'll send you a bit more through like a near. There we go.
So I'm just trying to get Sepolia working on my MetaMask because I don't know how to. Here we go.
Yeah, I have mine set up on here because I'm so scared that I'm actually going to swap to mainnet and just send all my funds. So I have it in a different browser. But yeah, I should be able to request a signature to your address, and it'll make my wallet pop up. Enter in my password. You can see how much Near I'm depositing, but if I'm using less Near than this, remember, I'll get the deposit back. Send that. Take a while to get the signature. We'll see. Will it go through? Hopefully. Fingers crossed. Whilst we're waiting. Oh, there we go. So we've got the signature from the MPC service, and now we'll try and relay it to the chain. So we're relaying to Ethereum network. It might take a while. It's good to know because it's taking a bit of a while.
Okay, so what is not possible yet is to have both of these steps in one, or is it just for being able to these 5 steps? Okay, now we can request a signature. It's all just being done one by one to showcase this, and we could also do it automatically, but it would just be under the hood.
Yeah, you could have a button where it's just like send funds, and you would just say like await signature and then relay it. But in this example, it's 2 separate steps just for the aid of learning, I suppose.
Yes, yeah, it makes total sense. It's cool. Now
so this worked, right? So I can see that I got a link, and it shows that I had 0.0005 ETH sent to your address, and you should see that your balance went up a little bit more. And what else? So that was just a transfer. We can also call a counter, which is just some contract on Sepolia Ethereum, and we can just add in some data here and request
I've just sent Ethereum to my MetaMask wallet as well. That's
cool.
That's pretty neat. Awesome.
But
super cool. I didn't even know that it would be able to create these transactions this easily. If you just clone the repository and you just install it, even without dev knowledge, you can just try it out. I wasn't aware that this was a thing. And you could just do it on mainnet if you just put in the addresses. and change
Yeah,
the
you could.
RPC.
I would maybe not recommend that. To start with, I would practice with testnet to start with, and then go over to mainnet if you're brave.
Oh yeah, no. First, I will try to create something like a near testnet and the Sepolia Ethereum token swap. But it looks very easy. So not very easy, but it looks manageable, more manageable than before this call. It's really hard for me to always just stare at code. And I mean, it's explained everywhere pretty well. I wouldn't even fault the near documentation, but it's just the way I learned to just talk it through once and be able to ask a couple of questions just makes it a bit more, I don't know, it's easier for my brain to process.
Yes, starting is always the most
Yeah.
difficult thing.
So now I see I have a very odd balance. So I started with 0.05 and you sent, I have done a transaction and I got sent something and now I have like 0.053719.
Yeah, mine is very long. You could round that, I'm sure.
No, I'm just wondering. So in this case, it wasn't doing, it was taking the transaction fees from the actual ETH balance and it wasn't using near funds, right? Because we haven't, this is not part of this contract to have, what was the name for that? That is a specific name as well, using non-native ETH funds to pay for your transaction fee.
Yeah, so all the transactions at the moment in this example is being used with like the native gas token, which may not be a good onboarding experience. For example, if we were wanting to call this counter where we're not actually attaching any funds, we would still have to deposit funds to process that transaction. But you can use a thing called a gas relayer, which basically uses an oracle to see what is the near price and what is the price of the gas token like Ethereum. And you just pay a certain amount of near or NEP 141 token like native USDC on near, and it will swap that for you and then like send it to your account so you can sign transactions without needing to hold gas on the target chain.
So the only thing that I would be worrying about is just how do I figure out how large the fees are going to be, because I am not confirming anything on the Ethereum side and there's just less balance after that. So if ETH has just a very popular NFT mint or something and the gas price is really high, then it's just confirming it without it needing to be confirmed by the user.
Yeah, I think what you would do in that case is like query what the gas price is, maybe add a little bit more, and then you would input that into the gas station of like how much gas do I need and how much tokens do I need.
So you just the only shot you have right now is to display it on the front end because the wallets are not handling it yet.
Yeah, there is no implementation of wallets that I'm aware of.
Yeah.
But I mean, if anyone's listening, feel free to do that for your hackathon project.
Yeah. I mean, let's go wallets. So I've just tried calling counter and this didn't work for me. So maybe you can have a try.
Sometimes you have to wait like a certain amount of time for your ETH balance to arrive for you to be able to sign the transaction, just because it's like awaiting confirmations, I think. That's why I didn't use the account where I just received funds on to sign. I used the account where I had funds on before just to get around that.
Just saying, not every chain has a confirmation time of 1 second. We are spoiled here on Nia.
But
Yeah,
whilst we're waiting,
that part worked. Just like for you, and then
well, the signature work, we'll see if the relay works. It's taking its time, so it probably means it works. Let's have a look.
yeah, when it failed for me, it was quicker.
Yeah, it's probably waiting.
So why is it saying amount Ethereum units? Because we're not transacting anything. Is this for the gas fee?
Oh, this is because I was using a web wallet. It's just swapped back over because the page refreshed. I suppose we need to implement it, so it checks what transaction was signed.
Everything on the above relay transaction is basically for the next transaction. It has nothing to do with our relay transaction. Okay.
Yeah. Because if we go into here, then
yeah, makes sense.
It's the same. But you could, well,
yeah,
for
your
some
current
reason,
number is 1005, so it apparently worked.
Yeah, for some reason I'm not getting the successful response, but it changed the number, so
yeah,
I guess it did work. If I look into the Explorer, I'm sure it'll say. We'll have a look at how that data bit is done, because like I said earlier, that where are we? There's this extra data value you can put in the transaction, and for the transfer example, it's
I just
nothing.
got a successful message
For the counter?
Yeah, I changed it to
Nice.
1001.
Yeah. Was it changed on my end? Ah, yeah. Oh, I finally got the transaction successful. Yeah, I can see you sent it. So this data bit, let's have a look where this comes from. Data. Create transaction data. So that's set up a new contract. Receiver ABI.
So, okay. Where did you go now? What's your goal right now?
I'm trying to look at how this data is constructed, this data argument, so we can see how to send like custom transactions instead of just transferring Ethereum
and calling functions on contracts and stuff.
Yeah. So
I mean, that is probably then just you can just some Ethereum research basically.
Yeah, it'll be Ethereum specific. So it looks like we're creating a new contract object, which is imported from the Ethers library, and it takes the receiver. So what is the contract address and the ABI for that? And the ABI is just like, what's the interface of the contract? And then once we have that contract object, we just do like encode the data. So what methods are we using from the ABI, and what arguments are we passing? So the one thing we need to look at is where the ABI is coming from. And we have the same thing for a view function, which shows us what the contract is. So where
it's funny. I mean, it's in hexadecimal. I don't know if probably the method has a real name. I'm just in the Sepolia Etherscan, and the method ID is just hexadecimal, but I guess it's just hexadecimal converted from letters or something.
What do you mean, sorry?
I was looking up the change number function call on this Etherscan, and it's showing me a method ID in hexadecimal. So
Oh,
just
right.
put it in the chat. The method ID is like 0x60f, yada yada yada.
Yeah,
But
maybe you need to convert
yeah,
that. Or
it probably is just change number in hexadecimal or something.
yeah, I'm not too familiar with Ethereum, to be honest. When you knock on near blocks, it just tells you like what the name is, right?
Yeah.
Yeah, so we're defining this ABI in this component, it seems. And that has, yeah, it should be the hexadecimal for set. So we have set, get, num, which are just some functions, and we have the contract name in there. And then we'll do this view function, and there should be the create transaction data. So it seems pretty simple to create a new like custom transaction, and I suppose you'll just need to change what the ABI is, and you can use this same method. So you should be able to just fork this example. Easy enough. That's pretty much it from that example. Do you want to
Awesome.
do you have any questions, or should
Yeah, I
we
would
sort
just
of
yeah, I mean, we can call it quits in a moment. I just had in my mind for the swapping example, we don't need to do anything extra then. So if somebody wants to create an order and wants to exchange Ethereum to Near, they just call whatever contract I am creating, and this contract is basically supposed to go through these. The front end is going through the different steps, and then it's just making a function call to the MPC contract and also to my contract.
well, I think with this example of swapping, you're going to need more logic than this, because say me and you were swapping Ethereum for Near or whatever, then I could decide to send like one transaction without sending the another, and like how we basically we don't want to be with swapping, we don't actually want to be sending any Ethereum, because to send Ethereum, that costs gas on Near. It costs gas on Ethereum, and it has Ethereum finality. Instead, we want to move the transaction and the logic and the swapping onto Ethereum. So basically, think less about sending on the native chain and think more about swapping access to accounts. So if you were to say swap Ethereum for Near, what you would do is send money into this Ethereum account, and then once it's in this account, when I want to give this Ethereum to you, I instead say that this derived account is no longer owned by me, is now owned by you, and you can do whatever you want with that account.
But if I derive the same account name from my Near account, it will still come out as the same account name. Just I don't have the access to it anymore, right?
So yeah, this is where we have to implement like a proxy contract. So instead of just calling the NPC directly, we call a contract to call the NPC, and the derivation comes from the predecessor account ID. So it's coming from what contract or what account is calling the NPC, which will be this like order book contract. It won't be your specific account. And the order book contract just says like who has access to this account. But in reality, the contract has access to all the accounts. it just then divvies up who has access to which specific account. And if you remove the keys to the contract, then, well, no one really has, like, the contract doesn't really have access to it. It's dependent on the contract's logic, if that makes sense.
Mhm. Yeah, I'll have to think it through. Maybe we can text a bit about it moving forward. Because your protocol.
GitHub, let's do GitHub. Hell yeah.
So yeah, what I really have to look into are access keys and how to utilize them, because I think I don't fully understand them yet, and they are probably great tools after everything I've heard in the past by more experienced developers. And also, I would have just thought, yeah, for every order that you want to create, you just have to pay transaction fees twice, which is obviously not really cool. Not really how it's supposed to be. What I've just thought,
yeah, that's why we use like, if you want good UX, you'd use gas station.
what I thought what you could do as well is you kind of broadcast the unsigned transaction, and the contract maybe stores the signed transaction, and the moment somebody accepts the transactions, it just fills it with the person that has accepted the order and its address, and then the transaction is being signed. But that doesn't make sense because the message changes, so does the signature, and therefore you can't do it this way.
Yeah, and the thing with like signing is that, yeah, you could decide to store the transaction in the contract if you wanted.
But there's a partial fill aspect of it. So if somebody wants to swap 1 Ethereum for 1,000 NIA, if somebody says, okay, I accept 10% of this order, you don't know in the end how many parts the order is going to be split, so you don't know how many transactions you have to broadcast beforehand. So this doesn't really work. So there has to be a more, yeah, I mean, this will take some thinking, but maybe you'll just have to let the person that takes the order or part of the order pay for the transaction fee. And then you must have 2 transactions. One is paid by the order creator, and the other one is the receiver that has to pay the final transaction to their account. Maybe there's no way around it.
How I would probably do this, like, order book is you have like a near contract, and you create an order in that near contract, and when you create the order, it says like how much Ethereum I want depositing in there, and from that action it like spins up a new path, like a random path, or it could be a path dependent on like a counter inside the contract, and it creates an Ethereum address, and that Ethereum address will be where you deposit in for that order. And you could do it so like you could confirm that this is happening in the front end, but this would probably only work for full orders. So if you like send the full amount, then you can say, hey, we're both happy that this has been filled, so we're going to make the swap, like we're going to change who has access to these 2 accounts. Or how you could do it, which would be better but more complex, is you use like something like a light client to confirm like which Ethereum address has deposited how much, and then like actually take that from Ethereum, on that logic on Ethereum, into NEAR. I think that would work.
I just dabble around with what you've shown me today, and then I'll have to figure out a solution for the problem at hand and how to implement it, because there are certainly also limitations, and not only what makes sense logically, but also what I'm able to implement from scratch right now.
So you got like if you're doing this hackathon, you have quite a while though. So I think you can
Yeah,
get a bit done.
yeah, we will see. I mean, at
Let's
least for like if there wasn't a partial fill, like the single fill version of all of this sounds pretty easily implementable because you can just change the access keys to whoever fills the order. But what makes it a bit dicey is the partial fill and the transaction fees,
yeah.
because you just the person who's taking the order is supposed to pay the transaction fees. We could deduct it from the amount that is in the order, but then we have to make sure that the amount that somebody has exchanged is above the actual transaction fee itself, so that actually you can pay the transaction fee at all. And yeah, it's there are different ways of implementing this, but yeah, for now, I think I have a good starting point of moving forward and actually understanding how we can create payload and how it works and how I can call functions.
I
And
think
maybe
it would be useful to quickly walk through this example.
okay, yeah, go ahead.
And this example is basically what I was talking about, like a proxy contract, which allows you to swap access to foreign accounts. So I can swap like Ethereum for Bitcoin. And basically, this contract is working through NFT standards. So to swap an account, you swap it the same as you would swap an NFT. And it just has some extra functionalities where I can say that you have also access to my account, not just me. And what more this account does, it just has like an extra method where you can send transactions to it, send payloads to it, and you just specify which NFT we're using and then the payload. And let's take a quick look at it. I think it was CKT sign hash. Yeah, here we go. So yeah, when you call this function, it just takes the token ID, another path if you want to specify that, the payload, and you can sort of forget about this approval ID. And yeah, so this basically just has some logic to check that it's the expected owner, and then actually sends the transaction to the NPC service and does some callback logic. But it's quite a difficult implementation, but the contract at a high level is relatively simple. So if you want to implement some sort of swapping mechanism, I definitely recommend that you take a look at this contract to base it upon. Or instead you can have like another contract that instead of signing transactions through the NFTs, you just check whether you own an NFT and allow you to sign a transaction based upon that. But yeah, that's the contract. Pretty simple.
Okay. Yeah, I'll take a look at it.
Any more final questions before we wrap up?
No, I think I'm good. Thanks for your time. And
thank you as well.
Look forward to make my hands dirty, and then yeah, I'm pretty sure we'll see each other in the dev chat, because it always sounds easier in theory than going on the keyboard.